Determine the values of sine theta, cosine theta, and tangent theta when. So for part A, we're going to consider when theta is equal to pi on 2 radians. So we're going to find sine of pi on 2, cosine of pi on 2, and tangent of pi on 2. So pi on 2 radians is the same as 90 degrees, so it's this angle that's created here. And when we're looking for these values, we need to remember that sine of an angle is read off the y value. So sine of pi on 2 is 1, cosine of pi on 2 is 0, and if we extended this value up until we intersect the tangent line, we'd find that that never happens, because pi on 2, that angle there, is parallel to our tangent line, so this is undefined. For part B, we're going to look at sine of pi, cosine of pi, and tangent of pi. So pi radians is at this position on the unit circle. And again, we look at the coordinates of this point here, and we have the y value, which is sine, is 0. We have the x value, which is cosine, is -1. And if we extend this back until it hits the tangent, we can see that the tangent value is 0. We're going to do the same thing now for theta equals 3 pi on 2. So 3 pi on 2 radians takes us around to the 270 degree mark, which is just here. And we again inspect the coordinates of that point on the unit circle, and we see that the y value is -1, so sine of 3 pi on 2 is -1. Cosine is 0, that's the x value. And if we were to extend this line until it intersected the tangent line, we'd see that that never happens, so this is undefined. For part D, we're going to look at 2 pi radian. So that brings us all the way around, which is the same as what 0 radians would be. So we look at the coordinate, and we can see that the y value, which is sine of 2 pi, is 0. Cosine, which is the x value, is 1. And finally, tangent of 2 pi, this intersects the tangent line at a y value of 0. For part E, we're looking at 7 pi on 2 as our angle. So 7 pi on 2 is actually 2 pi, which is 4 pi on 2, plus another 3 pi on 2. So that takes us all the way around once, and then we go around to 3 pi on 2. So we're here, and these values here for 7 pi on 2 should be equal to the 3 pi on 2 that we found in part C. So just checking, our y value, which is sine of 7 pi on 2, is -1. Our cosine value of 7 pi on 2 is 0, read off the x-axis, and our tangent value, again, if we extended this down, we'd find that it never intersects because they're parallel lines, so it is undefined. And now finally for part F, we're going to consider theta is minus pi on 2 radian, which is this direction by pi on 2 radian, or 90 degrees. So we're at this same point here. So minus pi on 2 radian should have the same values as 3 pi on 2 radian, which we found in part C. So just to check once again, the y value, which is the sine value, is -1. The x value is the cosine value, which is 0. And tan of -pi on 2, once again, if we extend that value, we find that it never reaches the tangent line. There's no point of intersection, so that is undefined. So they are the exact values for sine, cosine, and tangent when we are at angles that lie on the axes of the unit circle. So pi on 2, pi, 3 pi on 2, 2 pi, etc.